Hi friends, welcome to another delivery of NFT tickets for your event. In this video series, we are learning together how to create an ERC1155 contract using the quick node guides on Polygon. We are also learning how to connect to this smart contract using Node, while developing a system that will allow us to market our tickets and verify NFT holders at the event entrance. So far, we have designed, uploaded, and learned how to deploy and mint each of our NFTs. In the last delivery, we created a React application that connects to our Phantom wallet. This wallet allows to view your NFT tickets on your mobile and interact with our React application through the browser integrated into the wallet. Today, we will expand our application so that guests at our party can mint their own NFTs and view them in their wallet. To make things more interesting, we will modify the smart contract we created in the second part of this video series to fit the functionality we need in our application. We will explain this in more detail later. Let's locate the folder we created in the second part of our tutorial, which contains the ERC1155 token.sol and factory ERC1155.sol contracts. If you haven't done that part of the tutorial, we will leave a link in the description. First, we will open the ERC1155.sol file and add the following mapping: ID to minter, where we will store the address that mints each NFT. Now, inside the create mapping function, we will initialize this variable by placing the address 0 temporarily. We will create our getMinter function, which will return the address stored as the minter of the NFT with the ID we passed as a parameter. We will also create the isMinter function, which will verify if a particular address has already minted an NFT. Since in our solution, we will temporarily only allow one NFT to be minted per account. This function will loop through all the ID to minter pairs to verify and compare them with the address we are checking. If it finds a match, it will return true. If not, it will return false. This solution may not be the most efficient and scalable, but it helps us understand in simple terms how to program a smart contract in Solid. Finally, in this contract, we will implement a getNextID2mint function to know which ID will be the next to mint. This function uses the balance of function from the OpenSibling library, which returns the number of minted NFT for a specific ID belonging to an account that we pass as a parameter. In our case, the owner or holder of the NFTs is the account that deployed the contract and is the only one authorized to perform the setVerify operation we implemented earlier. We will also make sure to register the account that is minting in our ID to minter page. Now let's go to our factory ERC1155 file and create the function isMinter, which will simply return the result of calling the isMinter function that we created in the original contract for the token with the corresponding index. And we will do the same with the function getMinter, which will return the address stored in the ID to minter variable in the original contract for the ID we are requesting. Here, we will also create our getNextID2mint function, which we'll call the homonymous function we already created in the previous contract. An important step we will take is to modify the call to the mint function to send the wallet that is performing the minting as an argument, so that it can be properly registered in the contract. We save the changes, open a terminal in the indicated folder, and execute the migrate commands in the following way, and then the verification command. To deploy our contract, we can do it from Node using the code we developed in part 2. Remember to update the ABI file correctly and give a new name to this collection. We can also do this step from the Mumbai Polygon scan. Remember to have the corresponding data at hand. Let's go to Visual Studio Code in the folder we created in the previous video. And the first thing we will do is update our ABI contract.json with the ABI of the new contract and update the contract address with the new address in the following way. We will create this variable temp_contract_NFT and initialize it to null, where we will store the instance of the contract NFT that we will be interacting with. Remember to have your QuickNode RPC configured to work with the Polygon Mumbai testnet. In a future installment of this series, we will be moving to Polygon mainnet to be able to trade our tickets with real money, and for that we will be using a QuickNode RPC that works on the Polygon main network. We will create the getInstanceContract function that will create an instance of the NFT contract if it has not already been created, and if it has, it will simply return it. We store in this contract variable the new instance created with the contract method of the Web3 library for the Ethereum network that receives the ABI and the contract address. We must call this method asynchronously. We return our variable which has the instance of the contract. Now we will create the getTokenID2Mint function that will receive an instance of the contract NFT and will only access the getNextID2Mint function that we created in our contract and return an integer with the next ID to mint or 0 if there are no more available NFTs. We will create an isMinter function to determine if the client's wallet has already minted an NFT from our contract before. We do this because in our case we want to restrict the minted NFTs to only one per wallet. Our isMinter function simply saves the result of calling the isMinter function available for our contract with index 0 and the client's account. Now we will create our mint function to mint from the browser. First, we create or receive an instance of our contract. Then, we initialize a Web3 variable that will give us access to the functions of the Web3 library. We will verify if our client has previously minted using the isMinter function, and if so, we will interrupt the minting process, showing an alert. Now, we will call the getTokenID2Mint function we previously created to obtain the ID of the NFT we are going to mint. If the ID we is 0, it means that there are no more available tokens. Otherwise, we will start with the necessary steps to mint our NFT. The first thing we will do is to build the name of our NFT, which we will do by concatenating the first characters, NFT pass QuickNode party, with the number of the ID we obtained and storing it in a variable token named temp, taking into account the case of ID 10 as appropriate. Let's remember that for the NFTs to be minted correctly, their name must be spelled correctly, exactly the same as the name in our JSON file uploaded to NFT Storage. In the next step, we will encode the data of the mint ERC1155 function available for our contract instance using the encode ABI method. Remember that our function receives the index, which will always be 0 for our case, the name of the NFT we have created, and the quantity, which for our case will also always be 1. Now we will declare an object with all the necessary data to perform the minting transaction. We will call this object transaction parameters, and it will include the sender address of the transaction, in this case the wallet connected to the browser, the address to which the transaction is sent, which in this case is the contract address, the gas limit and price, and the encoded data of the function we just created. All we have to do now is to make the request using our provider with the sendTransaction method and the object that carries all the necessary information for the transaction. We will save the result in a constant result, and we add the appropriate error handling. Finally, we will create our minting button in the following way, and for our code, we will use the commands we already know: git add dot, git commit, and push. In the previous video, we explained how to create our repository on GitHub and deploy it to Vercel to perform our online test with HTTPS security certificates. We go to Vercel, and once our deployment is available, we visit the address, connect our wallet, and can press F12 to see in the browser the terminal with everything we have programmed to log on the screen. We press the mint button and we see that the isMinter function call is false, so we must approve the transaction to mint, and we also see that the token ID to be minted is 1. Remember that our code mints the IDs sequentially. After minting our NFT, if we try to mint again, we will see the following alert. And in our wallet we can see the NFT we minted from our app. If we want, we can test the code from our Phantom app using another account to make sure everything is correct. We hope this information has been useful. In our next video, we will use each of the functions and verify the tickets for each of our guesses. See you in the next one.